So it may seem like we're switching gears completely when we start talking about matrices, but we're really not. We are going to be pulling those systems of equations back into this topic. So we have to understand what matrices are before we can apply them to systems of equations. So first of all, a matrix is an array of numbers, characters, symbols, or variables. That just means you have these square brackets with elements inside that are arranged in rows and columns. So just like in an Excel spreadsheet or any kind of spreadsheet, your rows go across or horizontally and your columns are vertical. It works the same way in a matrix. And the size of a matrix is determined by the rows and columns. So if you're looking at this matrix, the size of it would be 3 rows, 3 columns. So the size of matrix A is a 3 by 3. The size of matrix B, we have 3 rows, we have 2 columns. So this one is a 3 by 2. Knowing how to define the size of a matrix is really important, especially when you're using them in your calculator. But it will become more important whenever we get over here doing multiplication of matrices. So let's look at this next part. Each element has a specific name, and that name is a subscript beside a variable. Okay, that subscript means row and then column. So if you want to know what is A32, notice this is a little a. That means that is an element of matrix A. So A32 means in the 3rd row, the 2nd column. So A32 is actually -1. There's really nothing to do. You just go to the 3rd row, the 2nd column, and say what that element is. So B32 would be the 3rd row, the 2nd column. So B32 is 1/2. B21, that's the 2nd row, the 1st column. So that's going to be 7. So what if I happen to say, what is B33? Well, we do have a 3rd row, but we don't have a 3rd column. So this does not exist. Okay, DNE means does not exist. Okay, so whenever you're adding or subtracting matrices, having technical difficulties again. Sorry guys, I hope it's recording okay. So when you're adding matrices, first of all, they have to be the same size. And whenever you do add or subtract them, you literally add corresponding elements. So 4 plus 5, 1 plus 9, 3 plus 0, 2 plus 7, if you're looking for A plus B. So notice this is a 2 by 2, and this is a 2 by 2. Which means we are allowed to add them. There goes my dog barking at the motorcycle. Alright, so we add corresponding elements. I'm going to write out this step. If you don't, I'm totally okay with that though. That's 4 plus 5, 1 plus 9, 3 plus 0, and 2 plus 7. That gives us the matrix 9, 10, 3, 9. We have now found matrix A plus matrix B. If you're asked to subtract them, it works the same way. You just have to be really, really careful with the minus. So if you want A minus B, these elements minus these elements, this one is a 3 by 2, and this one is a 3 by 2, which means we are allowed to subtract them. So be really careful. It's 3 minus -6. -1 minus 1, 7 minus -3, 5 minus -8, -2 minus 0, and 2 minus 5. So this would be 9, -2, 10, 13, -2, -3. So what if you combine all of those? What if we want to find A plus B minus C? Well, this one's going to be a 3 by 2, and this one is also a 3 by 2. So when you add these together, you will end up with a 3 by 2, right? So A plus B is a, A minus B is a 3 by 2. Then you want to add that to a 2 by 3. Is that even possible? Can you add a 3 by 2 and a 2 by 3? Imagine if you're adding these two. That's a 3 by 2 and that's a 2 by 3. Could you add these? We don't have corresponding elements. So this particular operation is undefined. And it's undefined because the sizes don't match. So if you're multiplying a matrix by a scalar, that just means you have a number sitting outside the matrix. You literally just distribute that scalar to everything inside your matrix. So look at the first one. We have 3 times A, so 3 times all of this. Three times negative 6 is negative 18. 3 times 0, 3 times 2, 3 times 4, 3 times 10, and 3 times 14. I don't know what that is. So a negative 42. That's literally all you do. Just multiply everything inside by the number that's sitting on the outside. Okay, so let's put all of that together in one problem. We have 3 times A, you can see the picture of the page behind it. It's kind of funny. 3 times A plus 2 times B. So we're going to multiply all these by 3 and add it to whatever we get when we multiply all of these by 2. I need to change colors, don't I? Alright, so multiply everything in A by 3. So we'll have 3, negative 6, 0. 0, negative 3, 6, 12, 9, negative 18. And we want to add that to whatever we get when we multiply B by 2. So negative 2, 4, 2, 0, negative 6, 4, 0, 2, negative 8. Now we want to add these two together, and we can because they're both 3 by 3. 3 plus negative 2 is 1. Negative 6 plus 4 is negative 2. 0 plus 2 is 2. 0 plus 0. Negative 3 plus negative 6. 6 plus 4. 12 plus 0. 9 plus 2. Negative 18 minus 8.